In this lesson, we shall focus on mathematics that pertains differential calculus, but also the notion of functions and how we can find the tangents at any point on a function, but also we shall look at applications of these in terms of graphs and functions, how we graph functions, how we deal with concavity and aspects of that nature. The first question is on the first principles, and we keep refreshing with different questions. This is a different question here that we're going to do right now on the graphs and functions, but also we want to do this according to Isaac Newton on first principles. Okay, let's get started. Right, you've been given the quadratic function x squared plus 2 equals f of x, and we need to determine f prime of x from first principles. To do this, we proceed as follows. We take this into account, and we then say that f primed of x. So the minute the examiner says first principles, you write down the formula, and this is the limit as h approaches 0 of f of x plus h minus f of x all over h, like so. This is the formula. What do we do with this formula? We take this formula and we use this formula to find f primed of x. F primed of x, what kind of a mammal is this? This is what we call the derivative, the slope, the gradient of the function at any point, instantaneous slope. As h tends to 0, the limit, and you come to the function, which is x squared plus 2, and this is going to be x plus h all squared, plus 2 minus f of x, which is actually x squared plus 2, and this is all divided by h, like so. Moreover, f primed of x equals the limit. As h approaches 0, you have x squared 2xh plus h squared. So if you square these, you write x squared. Next, you write 2 times x times h, or x times h, which is xh times 2, 2xh, and you square the h. And this is plus 2 minus x squared minus 2, all divided by h. This becomes the limit as h tends to 0 of the following. I told you this week is all mathematics. Every day, math, science, they're going to come in. Yeah. Right. So at this point, 2 and minus 2, they give us 0. We're left with 2xh plus h squared all over h, like so, becoming the limit. As h approaches 0, h is factored out, 2x plus h all over h. And we proceed to solve. H divides. We have the limit as h tends to 0 of twice x plus h. And this is what we are able to achieve. As h tends to 0, this is 2x plus 0, giving us 2x. So at this point, we are able to take note of the fact that we have this here. So this is therefore the conclusion that f primed of x equals 2x, and this is the answer. What was the question? The question was, given f of x equals x squared plus 2, determine f primed of x from first principles, and that's what we're doing. Okay, this week we shall be doing a lot of graphs and functions. Grade 11s, get ready. I'm going to be looking at sections per question paper. So we're going to be focusing on sections to make sure that each of you is aware, but also is very prepared to deal with a lot of exam questions. Per section is going to be our focus this week. Take note of that. Next question. Right, now we need to determine the dy dx notation. Okay, some of you are seeing this thing for the first time, and what is this? This kind of a mammal, this object here is called the operator, and it's called the dy dx. So the way we read these, we say dy dx. It's not dy over dx. It's not division. This is called an operator, and operators are not divided. Okay, we continue now to solve this problem. To solve this kind of problems here, we use a rule we call the power rule. We use a rule we call the power rule. What is the power rule? The power rule says x to the power n will therefore imply dy dx, and dy dx is nx to the power n minus 1. This is called the power rule. What does the power rule state in words? It says if y is the power of x to the n, then we can bring, and we always do when finding the derivative at any point, we bring down n and subtract 1 from n. Take note of this. As a consequence, we say, to do 7.2.1, here is our first question. 4x cubed plus 2 divided by x. Y equals, we must write everything in power form to use the power rule. And therefore, this is 2. The x is to the power 1 sitting in the denominator. We bring it to the top, attaining a negative index, like so. We continue to manipulate using the power rule of differential calculus. This section we're doing is called differential. What kind of a topic is this? It's called differential calculus. Right, so it is called differential calculus. Yes, definitely. You always do that. So when you're doing what you call differential calculus, it is the calculus of the derivatives of dy dx. Okay, you learned this. Right, so you continue to drop everything, and this is dy dx. Okay, because the examiner says find dy dx in this question paper. So you have 4 times 3, and it becomes x to the power 3 minus 1. So you subtract, you always drop the n and then subtract 1 from the power. The power is 3 here. You drop 3 and you subtract 1 from 3, like as we've done here, to have 3 minus 1 plus 2. And we drop the power, because it's the power rule we're using. We drop the power minus 1 and we subtract 1, like so. Okay, what is this in the end? This in the end will then mean that we have dy dx. So this implies, this symbol is called the implication symbol. And 4 by 3 is 12. X to the power 3 minus 1 becomes a 2. Now 2 times minus 1 becomes a minus 2x to the minus 2, like so, giving us dy dx equals the 12x squared we desire minus 2. The negative index, please always write your answers with positive indices, positive exponents, and we have achieved the result, and this is the derivative at any point called the instantaneous rate of change. It is the instantaneous derivative, the instantaneous speed, the instantaneous acceleration. These things enjoy a lot of applications in engineering, science, and technology. We continue to solve even more and more problems in the area of advanced mathematics, that is differential calculus. The next question is as follows. We continue to do the next one. The next question is 7.2.2, and the examiner is saying we have been given y equals 4 times the cube root of x plus 3x cubed all squared. And we must write everything in power form, and this is 4x to the power 1/3. Right, and then now we square everything here, and if we do, it becomes 3 squared, and it becomes x to the power, then we have 3 times 2. Like so, giving us 4. Y equals 4, x to the power 1/3. 3 squared is a 9, x. 3 times 2 gives us 6. Right, we shall calculate volumes of cones and surfaces today. Now, we continue to then say, let us find the derivative at any point. This is read dy dx, but not dy over dx. So students must learn. These are operators, and this is called operator theory. So you bring down the power, and you subtract 1 from the exponent, like so. 9, you bring down the 6, and you subtract 1 from the power, getting dy dx equals 4 times 1/3. 1/3 minus 1, which is minus 2/3. 9 by 6. 9 times 6. And 9 times 6, you already know very well, it's a 54. 9 times 6 gives us 54, x to the power 6 minus 1, giving us the power 5. And therefore, this is 4 out of 3. 1 divided by x to the power 2 out of 3. And then here, this is 54 x to the 5th power. This is the derivative, and this is the slope at any point of the function. Right, so if you have a question, make sure that you ask. Right, so if you understand what we're doing, you ask. If you have a question, you let us know and we can see what to do. Yeah. Yes. Yes, siyaphila njani? Yebo. Okay, that's fine. Yeah, saseclassini until 10. Yeah, ngiyavisisa. Yeah, but saseclassini manje ngiyafundisa until 10 tonight, you know.
Okay.
Yeah, yeah, so yeah, I'll let you know nangiceda after 10, like around 10:15. Yeah, I'll find WhatsApp, yeah. Yeah, that's fine. That's fine. Okay, yeah. Some seat. Okay, thanks then. Okay, goodbye. Bye. Right, so we continue, guys, and look at 7.3 now. And 7.3 is a very interesting question. And we're looking at if G is a linear function. So looking at linear functions, we continue as follows. The linear functions themselves are very, very exciting, but also they're so good for us. If G is a linear function with G of 1 equals 5, right, and G prime of 3 equals 2, determine the equation of G in the form Y equals something. So let us look at this question, but let's make sure we understand this question together in the context of what we call differential calculus. Because now this is not the inverse, okay? The inverse functions we'll learn, but this prime here is called, constitutes the section we call differential calculus. And differential calculus is very important because it helps us to find the rates of change, to maximize profits, to minimize profits, to calculate losses, to determine the speed of a moving car, to determine the speed of a flying airplane in engineering, science, and technology. We continue to then solve this if G is a linear function with G at 1 equals 5, G prime at 3 equals 2, determine the equation of G in the form Y equals something. So then what we then do, we do the following. Now, students need to pay particular attention to it. If you have been given that G at 1 is 5, so there's a point of contact that examiner gives. And the point of contact is that it has X is 1, and Y is 5. That is the point of contact. Okay, first things first. Next, the derivative of the function G at 3 equals 2, and that gives us the slope. And the slope is the gradient, is also called M, and the M notation for the gradient is used in analytical geometry. The grade 11s know this, and the matrix know this. Now, determine the equation of G in that form. Right, so we then continue as follows. Right, so we continue to solve the questions. We continue to solve the questions as follows. Okay, right. So, all right, yeah. Yes, any question? Mamba.
Yes,
Mamba.
sir.
Yes, Mamba, you have a question.
Yes. Isho ukuthini le 3 ngaphakathi kwama-bracket?
Yes, the 3 within brackets is actually telling us that we are having here an X value. Right, we're having an X value, and the X value is 3. Right, so
Yes.
in other words, G prime, the derivative, that would mean the derivative at 3 is 2. Okay, so here, this is G at 1. But remember that G is a linear function. What is a linear function? Linear function is a straight line. So a straight line will have the same slope at any point. Okay, here's a straight line, and here is the This is the y-axis, and this is the x-axis. Okay, good. Now, we have that g at 1 is 5. So there's a point, right? It is a point on the function where x is 1 and y is 5, and we have this point, right? So
Yes.
1 together with 5. And this is telling us that the derivative at x equals 3. Where is x equals 3? Remember, a linear function, the word linear means straight, right? So it's a line. So now, there is another point where x is 3, because when x equals 3, then you can find the derivative at that point, so that g prime is 3 equals 2. And this examiner is telling us that, hang on, guys, do not worry, because the slope is 2 at x equals 3. But doesn't matter, a straight line has the same slope at any point. Even if you can take the slope at this point, it's going to be, you see, you can take the slope here at x. X can be anything. Maybe x is equal to minus 20. All right, what is going to be g at minus 20? What is going to be g prime, the slope? If this is a straight line, the slope is going to be the same.
2.
It's going to be 2.
Yes.
Okay, good. So if you take the slope and you say, okay, this is x and x is minus 100, the slope is still at g primed at minus 100. It's still going to be 2. Right, so obviously the fact that the examiner is saying it is g primed at 3, the slope, g primed at 3 equals 2, telling us that the slope is 2. Remember, it's a linear function, so it doesn't matter the x value. The slope is the same at any point. But the examiner is telling us that it is at x equals 3 that the slope was calculated. Okay, we're good.
Thank you.
Okay, good. Right, so the next thing that we're going to do right now is to answer the question and to determine the equation of g in that form. So, yeah, we're good, Mr. Examiner. And we then say, what formula do we use to find the equation of a line? I love this one. Right, we love this. So y minus y1 equals m into x minus x1. But this line, examiner taught us and told us that it passes through the point of contact. What is the point? Right, the point through which it passes has the coordinates 1 and 5. And these two coordinates here have the x, which is called the abscissa, and this y component, which is called the ordinate. Right, so at this point, this will give us x1 together with y1, and we continue in our red color, and this is y minus y1, which is 5. The slope is exactly what? Is 2. X minus x1 is 1. Okay, y equals 2 times x, 2x, 2 times by distribution, 2 times x, and 2 times minus 1. So 2 times minus 1 is minus 2, and then you add a 5. So now, which is 2x plus 3. This is the equation of the line, 2x plus 3, and this is the answer to the problem. Okay, good. This is the answer. And hence, this one, Mr. Examiner, is what we want. Because now we're then going to come and say g of x. What is g of x? Because right, in particular, the examiner said, write it in the form y equals something. So we're done. We're done. So you can even remove this. So we're done and we're excited. And this is the answer to the question. What is the answer? The answer is y equals 2x plus 3. And that is the answer. And that is the answer. So we continue to evaluate the next and to solve the next question. This one is a very important question. You can see it, you can even meet this at grade 10, you can meet this one at grade 11, you can meet this one at matric. So it's a very versatile question, but pay attention as we move to solve the next problem. Right, in the next question, the examiner is becoming more creative. And in question 8, the examiner, because we're looking at graphs and functions as they relate to differential calculus, a cubic function defined by h of x equals minus 2x cubed plus bx squared plus cx plus d cuts the x-axis at minus 3 and 0, minus 3 over 2 and 0, and 1 and 0. Show that h of x equals minus 2x cubed minus 7x squared plus 9. We're going to proceed to solve the first question. Right, to solve the first question, the examiner says, if you have been given all these things, show that the equation is this. So we shall proceed to show that the equation of that, but we shall show that in a step-by-step fashion as follows. Now, we use a specific formula to do this particular calculation. We use the formula y equals. Right, so we shall use the formula y, but we can also call the formula h. Right, you can also call the formula h of x. So you take the coefficients. So in general, I must indicate the general formula because we are learning here. Just write the general formula for everybody to see. Right, so we write first y. A, open bracket, x minus x1, x minus x2, x minus x3. This one is x1, this one is x2, and this one is actually x3. Pay attention to what is happening here because we are exploring to the greatest depth possible our differential calculus section for the metric and grade 11 syllabi. Okay, at this point, we have that the coefficient of the cubic term is -2, so that is our A. Put -2 there, and we have x minus the first x intercept -3. You put the -3, but put it with its sign x minus the x2. You have -3 over 2, and x minus the x3. It's a 1. Okay, this coming week, every day at 8 p.m. after school, 8 p.m. we have mathematics and science. Okay, so we have -2x plus. So this is going to be x plus 3 plus 3 over 2, this one, -1, this one. Okay, what is all these? We continue to expand, explore, and calculate. We continue to expand, explore, and compute. Right, so this is y that equals the following. So we have -2. Let us just rearrange this. Let's put this one here. The x plus 3 over 2 first. Have x plus 3 and have x minus 1. -2, and we have x plus 3 over 2. We multiply x by x. It's actually x squared. So x by x is x squared. X by -1 is -x. 3 by x is 3x. 3 by -1 is -3. -2 open bracket, x plus 3 over 2. X squared plus, okay, we have -x plus 3x. -x plus 3x will give us 2x, and this is -3. By distribution, we continue to perform algebraic distribution within the parentheses, and this gives us the following: -2. If you then multiply within the parentheses and multiply as follows, what then are we able to achieve here in a step-by-step fashion? Right, this is good news for us, because if you take the 2, okay, there's a 2 here, and this 2, you take it and you multiply 2 by x, 2x. 2 by 3 over 2, it just be 3. Okay, now this one, this is a trinomial, x squared plus 2x minus 3. Okay, we have this trinomial, and you perform further algebraic distribution. Minus, open bracket, 2x by x squared is 2x cubed. Now, 2x by 2x, 4x squared, 2x by -3, -6x, 3 by x squared, 3x squared, 3 by 2x is exactly 6x. 3 by -3, it's a -9. Everything is carried forward to the top over here. And we're going to finish this off in red ink. Okay. So y is equal to open bracket. Yes, please. Any question?
Sir, is it wrong to start by multiplying the bracket before we use the 2?
Yeah, it's correct. It's correct to do so, but it's just that the two was helpful because it removed a fraction before we could add everything. We do not want to, to mess everything up with the fractions. So the 2 was very ideal because the 2 just removed this fraction and made everything nice, because if you could multiply the brackets, then we would have the 3 over 2 getting mixed up with everything. And now it will make our lives messy, and then we'll have too many terms with fractions inside. But just a single multiplication by the 2 cancelled these 2 here, and we have no fractions left at this point, and we can work beautifully because fractions are not ideal to deal with. I mean, they're very cumbersome. Okay, right. So, but it's okay. It's okay. The answers will be the same in the end. Right, so you have 2x cubed here, and you have here 4x squared and 3x squared, and 4x squared and 3x squared together give us exactly 7x squared, giving us a 7x squared here. Next, right, we have the minus 9 here that sits at the end. So that we have minus 2x cubed minus 7x squared plus 9. So this is the answer. And so this becomes the result, and we're done. So, okay, we check how far are we. The examiner said show that h of x equals minus 2x cubed minus 7x squared plus 9, and it is exactly what we got. It's exactly what we got. But we used this formula here. Take note of this green formula. Y equals a open bracket x minus x1 close bracket open bracket x minus x2 close bracket open bracket x minus x3 close bracket. Okay, take note of that formula because it works as long as we have what you call cubic functions. Yeah. Earlier on, I spoke about the one for quadratics. When we have quadratics, we use another one for the quadratics. Okay, let us continue right now to solve. Yes, any question?
So, sir, the formula, does it work only when we have x-intercepts?
Yes, it works only when we have x-intercepts. That's correct. Only when we have x-intercepts, because the examiner here gave us the 3 x-intercepts, 1, 2, 3. All these 3 points are x-intercepts, and the formula works. Okay, it works only if you have x-intercepts, correct.
So if we do not have the x-intercept, what do we use then?
Okay, yeah, we use other formulas. I'm gonna teach you other formulas that we use. The other formulas that we use when we do not have x-intercepts, and I'm gonna explain those because there are some exam questions that are gonna appear, and we're gonna solve some other exam questions where the x-intercepts are not given, and we use other techniques, and I'm gonna elaborate on those methods. The next question.
Okay.
All right. So now at this point, I want us to focus on 8.2 and want to calculate the x-coordinates of the turning points of H. The x-coordinates of the turning points of H. Now, we need to remember something that is very profound, but also what the examiner just gave to us. We need to remember now, we were solving question 8.2, and in solving question 8.2, we remember that H of x was proven, and we proved that H of x was minus 2x cubed minus 7x squared plus 9. Okay, we want to find the x-coordinates of the turning points. How do we calculate turning points? We do h primed of x. H primed of x, then we drop. Right, we bring down 3, and it multiplies the 2. We subtract 1 from the power. This is called the power rule. Okay, I'm going to state the power rule for people to always remember. Y equals x to the power n. This implies that dy dx. dy dx is xn to the power n minus 1, and this is called the power rule. The power rule says drop the power and subtract 1 from the power after dropping it. Okay, so we bring down the 3, we drop the 3, and we subtract 1 from the 3. Next, we have minus 7. We drop the 2 and we subtract 1 from the 2. We find the derivative of the number 9. Number 9 is called a constant, and the derivative of a constant is 0. Right, getting h primed of x, which equals, what is minus 2 times 3? It's a minus 6x squared. Minus 7 by 2 is 14x. And we have 2 minus 1 here, which is to the power 1. The power 1 is never written, so we leave it that way. But to find the coordinates of the turning points, we equate these to 0. And at this point, we take out the highest common factor here from this expression. And the highest common factor that we can take out is the following. Doesn't really matter what you do. You can take out minus 2x. Right. Taking out minus 2x here is going to give us exactly 3x, and it's going to give us plus 7, and the result is a big naught. Pay attention. This means x is 0, or x equals minus 7 out of 3, and this is the answer. These are the 2 answers. But what do we do with these 2 answers? Hang on, they are the answers the examiner asked for. What did the examiner ask us to do exactly? They asked us to determine to calculate the coordinates of the turning points of the function at our disposal. And the function at our disposal is the function h, and we've got x equals 0 or x equals minus 7/3. And we are done. Just only the x coordinates, please, not the y coordinates, students. The x coordinates, and the marks given were 3 in that exam paper. Yes, Nambuso, any question?
Sir,
Yes.
if ngiyenze bathi the layer x is equal to negative b over 2a to find x, I'm wrong.
Okay, if you use the formula x equals minus b over twice a,
Yes.
this formula is for a parabola. It is for a what? Parabola.
Parab-
And yeah, and a parabola, what is the equation of a parabola? A parabola has the equation ax squared plus bx plus c. Okay, and therefore it only works if you have a quadratic function. But this function we're dealing with, what do you call it with the power 3? It's called a cubic. Yeah, it is called a cubic what? Function. Okay, remember that our lesson is recorded. Even if I have a couple of breaks and I talk to you, but I'm going to post this lesson. I'm going to post this video after our lesson, and you shall have a chance to watch this again. Okay, so it's a cubic function. So this one works if only we have what? Works if only we have a parabola. There's another one that works for cubics. So x equals minus b works if the power is 2. That is why this is 2 here. Okay, the one that you're going to use if it's a cubic is not taught in high school, but it is this one here. You can only learn at university. Okay, it's for cubics, and the one for cubics is as follows. Okay, yeah, for cubics is x equals minus b over 3a. Okay, so this one here would be the one you can use when the power is 3. Okay, but when the power is 2, you're going to use 2a. Okay, so yeah, that's the thing. So what do we do? Obviously, at high school, the examiners will be very surprised to see you writing x equals minus b over 3a. Some will mark you wrong because it's not part of the memo, it's not part of the curriculum. And the examiners expect you to use derivatives and to just drop the powers and subtract 1, to drop the powers, they subtract 1, and to also realize that if there's a number which is called a constant, then derivative of that is going to be 0. See, the examiners always expect you to use what you call the power rule, but you can use all these here. There's another one. If the power is 4, what do you do? If the power is 4, you use the formula x equals minus b over 4a. X equals exactly minus b over 4a. So this one here, it's the formula when you have what you call a quartic equation. Okay, or what do you call a quartic function? Okay, so you use minus b over 4a. Here, minus b over, but you see, I'm not saying you must use only all these formulas here to get the examiners confused, because now they're going to be thinking you are a university student and you're still in matric. And for the matric students, they want you to drop the powers and subtract. And also, they expect you to use minus b over 2a when you're dealing with the quadratic function or the quadratic number patterns, you know, the quadratic sequences, etc., etc. Okay, next question. 8.3 is next. Right, in 8.3, the examiner is saying determine the values of x for which h will be decreasing. Values of x for which h will be decreasing. So we look at 8.3 right now and we analyze what that is supposed to mean. Right, so let us look at these together. So we're looking at 8.3. Right, to look at 8.3, the couple of things we ought to take into account. But we need to remember what h was is given to us. So we have h of x, which equals minus 2x cubed minus 7x squared plus 9. This is the function. The derivative can be obtained alternatively or very equivalently. Right, what is the derivative of this? We have saw that before. We drop the 3 and we multiply 2, getting a minus 6x, subtract 1 from 3, obtaining a 2, like so. we continue with the differentiation process until such time that differentiation has been carried out completely up to the end, meaning that we shall have minus 7 times 2. Okay, we know 7 times 2 gives us a minus 14. We're smart enough. We can just say, okay, 7 times 2 would give us exactly a minus 14x to the power 2 minus 1 gives us power 1. And we don't write the 1 there. The derivative of the number 9 is a constant, therefore it's 0. And we have that, and this is the answer. But look, determine the values of x for which h will be decreasing. If the function is decreasing, it means that if you have the y-axis and the x-axis, the decreasing function is going down, it's decreasing. Right? If it's decreasing, it means therefore that the derivative this is called the derivative. If you don't want to call it a derivative, you call it a what? You call it a slope. If you don't want to call it the slope, what do you call it? You call it a gradient. These are all equivalent points. And at this point, you then say, if the function is decreasing, it means that its gradient is negative. Its slope is negative. Okay, so we do this. And we need to solve for x at this point. And now we recall what we did, and we take out the highest common factor, minus 2x, giving us 3x exactly with a plus 7. This is negative. So that when you multiply, it becomes minus 6x squared minus 14x is less than 0. We are back to our question 1 on algebra. This is like algebra, and this is an inequality. So we calculate what we call the critical values. The critical values occur at x equal to 0 simultaneously at x equals negative 3 out of negative 7 out of 3. Right, this kind of a graph that is associated with this here is a very good one. Okay, so pay attention. Now, this kind of a graph is a graph that has a maximum vertex. Maximum vertex, and you therefore have that x is minus 3 over 7 and 0. Start with the smallest one, the negative 1, and you put the 0 there, like so. We're interested in the parts where, why is the graph like this now? The graph is like this because you look at the coefficient of the quadratic term, and it's negative. So it's going to have a maximum vertex. Going to have a maximum vertex. Pay attention. If it has a maximum vertex, this is the x-axis. What do? You take this into account and you say, we're interested in the parts where this function here, this one, is less than 0, negative. So where is this negative? It is 0 here. So we put opposite is 0 there. We're interested in the negative parts. It is negative here, but also it is negative there. Okay, so now we continue to answer the questions here, and we have most certainly the following there. So what is then the answer? So as a conclusion, we then say that x itself is less than minus 7/3, or x is actually such that it is bigger than 0. We go to the right of 0, which is bigger than 0. We go to the left of minus 7/3, so that x is less than minus 7/3. And this here is the answer to the problem. But look, this is not the only way to solve this problem. There are a couple of other techniques. Pay attention to what we do. We can say x is an element of the interval, so we can go to minus infinity, minus 7/3, or x is an element of, this one here is from 0 to infinity, like so. Okay, we're good. We're good. And yeah, we can say x is an element of this, minus infinity to, so we start all the way from minus infinity to minus 7/3, and then we have a gap here where there's no solution. Then we say union, 0 to infinity, like so. The next point, question 8.4 is next. This question was like, determine the values of x for which h will be decreasing. A decreasing function means the gradient is less than 0. The gradient is negative. Please pay attention to this. I'm going to pose more questions on the group for you to practice. I'm going to come with a new law for people to submit, and I mark the questions on the group, on the WhatsApp group. That's what I mean. Next point. Right, 8.4 is a beautiful question. And it says, for which values of x will there be a tangent to the curve of h that is parallel to this line here. Very creative examiner. Very, very creative examiner. A tangent to the curve H. Now, let's remember H. Let's write down H, but also simultaneously, we write down this one, which is y minus 4x equals 7, which means y equals 4x plus 7. Okay, what is H? What is H? It is actually minus 2x cubed minus 2x cubed minus 7x squared plus 9. And this gives us something very, very exciting. We need to find the gradient of a tangent. Because now we're saying for each of us of x, will there be a tangent to the curve of h? A tangent, let's find a tangent to the curve of h. Tangent to h means we must find the gradient, the slope, and therefore you have minus 2, you drop 3, and then you subtract 1 from 3, like so. 7 times. Drop the 2, subtract 1 from the top. The derivative of the 9, a constant, becomes identically 0. We move forward. Minus 2 times 3 will give us a minus 6x squared minus 14x. Like so. Exactly like so. And we obtain the following. So at this point, what we're then doing is we are understanding the question, because the examiner is then saying here in this particular question, for which values of x will there be a tangent? This is a tangent to the graph of h that is parallel to the line. Okay, two lines are parallel in geometry, in algebraic geometry. Two lines are parallel, where now there's line 1. So you can find the gradient of line 1, the gradient of line 2. So you will say the gradient of line 1 is equal to the gradient of line 2. And these gradients, so in other words, two lines are parallel to each other when the gradients are actually equal to each other. So that we have the gradient of line 1, gradient of line 2. So that line 1 is parallel to line 2. So we have that h primed is equal to 4, and therefore if this one, because you have the gradient is sitting here and the gradient sitting here is 4, this whole thing, the derivative, is called the gradient. Okay, so if we are to say the tangent to the graph of h, so there's a graph of h, and this graph of h is a tangent. The tangent is a line that touches at one point. It is parallel to this line. It is parallel to the line, so parallel like this, to the line y equals 4x plus 7. Pay attention. So if these are equal to each other, then we have the following. Let us manipulate this equation that the examiner has suggested for us. We move forward. We transpose this to the right-hand side, getting 6x squared, and we have plus 14x transposed to the right. We have plus 4, and this equals 0. And we further do division by the highest common factor, 2. 2 divides 6, giving us 3x squared plus 7x plus 2 equals 0. We move forward, and we are able to find the algebraic linear factors of the quadratic. Right, so the factors of 3x squared become 3x and x. The factors of 2 become 1 and 2, and we put a plus here. Okay, good. What is the next thing that we're supposed to do? What is the next thing that we ought to do? So we simplify this and we get the answer. We get the answer. What is the solution to this? Right, so the solution to this, then, it is x equals minus 1 over 3 or x equals minus 2. Okay, so that in the end, then, you are able to get the answer to this and to be the, get the distinction you want. Now, for which values of x will there be a tangent to the graph of h that is parallel to the line? Say, x equals minus 1/3 or x equals minus 2. And this is the answer. Next point. Next point. Question 9 is beautiful, but question 9 is full of good news. And the examiner is asking us a question. And the examiner is saying a cone with radius r centimeters and height AB. Right, so there's a cone. The cone is sitting inside here. And its height A, this is A and that is B, right, is inscribed in a sphere with center O. There's a sphere with center O, and this cone, people, good people, is inscribed, and there it is. The cone, there it is. The ice cream cone is sitting inside the sphere, and this sphere has a center, and this center is O of the sphere, and radius 8 centimeters. So the radius is 8 centimeters. So radius is the distance from the origin, from the center to the circumference 8 here, but also there's also in this one, which is also 8 here, the distance from the center of the sphere to the circumference, etc., etc. Right. So, but also OB is X. OB is X units. There it is. It is X units. So we continue. We continue to solve this particular question. Show that the volume of this, or rather calculate the volume of the sphere. Okay, there are two formulas the examiner suggests for us. Okay, obviously we need to know these, but examiner is a word that they're not given the back of the paper. So they're like, volume of a sphere is 4/3 pi r cubed. Volume of a cone is 1/3 pi r squared h. Okay, these two formulas, take note of these. They will save your life. But examiner goes on to say, calculate the volume of this sphere. Right, so the volume of the sphere, you're going to write here volume. Right, you're going to write volume of sphere. Right, just volume of sphere. What is volume of sphere? Well, sphere is 4/3 pi r cubed equals 4/3 pi. What is the radius? The radius is 8. Remember, we're dealing with a sphere with center O and radius 8, so it means R is 8 centimeters. That is the radius. So we come here and we substitute the radius and we put the radius here and we cube everything because the radius is cubed in the volume of a sphere, giving us 4/3 pi. Now we continue to multiply everything out, and we can actually be in a position to do this with so much simplicity and ease. Then let's proceed to do the calculation. So we have 8 cubed by 4. 8 cubed by 4, which is 2048. 2048 pi out of 3. 2048 pi out of 3, and this is the answer. And this becomes the answer to the question. And therefore, we have found the volume of a sphere. What are the units of the volume of a sphere? The units are cubic centimeters. These are cubic units because the radius is measured in centimeters, and therefore we're able to see that the volume of the sphere is cubic centimeters. The next question follows, but we are at liberty to express this as a decimal and then say, Mr. Examiner, if you do 2048 pi out of 3 on your calculator, you will get exactly the following. You'll get 2,144 and 66 cubic units, cubic centimeters. Right, so this is exactly 2,144 decimal comma 66 cubic centimeters. Take note of that. Next question. Right, in the next question, we want to show that the r squared equals 64 minus x squared. And let us do this. Next question. Right, in the next question, we want to show that the radius is this, and it's just 1 mark. And or rather, r is this. Okay, here is the r sitting there, then here is the x sitting there. The radius, distance from the center, is actually 8. It is 8 there. And then it is 8, then we shall confine ourselves in a triangle. We shall confine ourselves in the triangle and say 8 squared. Right, we shall say clearly 8 squared is equal to what? So 8 squared, which is a square on the hypotenuse, is equal to x squared. So we squared the x, but we also squared the r, and this is called Pythagoras. It is called Pythagoras. And now we want to make r the subject because we are to express it in this form, making r the subject. So we have r squared is actually 8 squared minus x squared, like so, meaning r squared is 8 squared, which is 64 minus x squared. Yeah, that is Pythagoras. That is Pythagoras. Okay, that's the answer. That is the answer. So, yeah, we're good. And we have expressed this in the required form. So that was for 1 mark, and we got the 1 mark there, and we move to the next question. So, yeah, next one. In the next question, we are celebrating, but very good news, and we are looking at what must be done next. And the next thing now we ought to do is to deal with this particular question here that sits in front of us. And we're much interested in solving these in a step-by-step fashion. So we're looking at question 9.1. Right, so looking at question 9.1, we need to make sure that we answer these questions, but we answer them very, very carefully. Right, so 9.1 itself is certainly a very, very good question, but how do we answer the questions here in a step-by-step manner? We start as follows. The first question. We repeat the first principles concept for everybody to master that. So determine f prime of x from first principles if it is given that f of x is 2x squared minus 3x. Let's get started. Right, so we have the following. Right, so at this point, we've been given f of x equals 2x squared minus 3x, and we are supposed to use first principles. Right, determine f prime of x from first principles, meaning f primed is the limit as h approaches 0 of f at x plus h minus f of x all over h. This is the limit as h tends to 0 of the f of x plus h is x plus h. You square that, minus 3 of x plus h minus, okay, so the f of x is 2x squared minus 3x, like so, all divided by h. All divided by h. We continue. We continue so that with f primed, with the limit as h tends to 0, 2 open bracket. If you square this one here, it becomes x squared. So we write down x squared. Next, we write down x times h, which is xh times 2, which is 2xh plus h squared minus 3x minus 3h. And then we have here minus 2x squared plus 3x all over h, like so. Next, this gives us f primed, the limit, as h tends to 0 of 2x squared plus, okay, 2 by 2 is plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. So we have 2x squared in that, minus 3x in that. And this, therefore, means you have the limit as h tends to 0 of 4xh, 2h squared, minus 3h all over h, giving us f primed is the limit h tends to 0, h open bracket, 4x, 2h, 3 divided by h. Okay, we've taken out the highest common factor from these. We've taken out the highest common factor with which is h, leaving us with 4x, 2h, and if you pull out h out of minus 3h, you get to minus 3, and now this h is going to cancel this one in the denominator. Okay, this cancellation called the cancellation law. And this cancellation law produces the limit as h tends to 0 of 4x plus 2h minus 3. Taking the limit as h tends to 0, 4x plus 2 times that minus 3, which is actually 4x minus 3. And this is the answer. So to determine f prime of x from first principles, if it is given that f of x equals 2x squared minus 3x, we get exactly 4x minus 3. Get exactly 4x minus 3. And this is the answer. And this is the answer. Right, so the next thing we're going to do is to solve. Okay, remember we used first principles, and first principles actually give us this result. Next point. Okay, let's look at 9.2.1. Let's look at 9.2.1. Now, 9.2.1 is about the rules. Determine dy dx. So yeah, the examiner says dy dx like this, and you need to determine this, and you need to use the rules. And the rule is actually what we call the power rule. What is the power rule? The power rule says y equals x to the n will therefore imply that dy dx equals nx to the power n minus 1. And this here is what we call the power rule of differentiation under the section we call differential. We call this differential calculus. We call this differential calculus, and we continue to solve even more problems in mathematics. Okay, how do we do dy dx given y equals? So we start with y equals 4x to the 5th power minus 6x to the 4th power plus 3x. And there's no power on the x, so we know the power is 1, like so. Next, we find then dy dx. Right, we drop. So what we do is we drop the power 5 and we subtract 1 from it. Minus 6. We drop the 4, the power 4, and we subtract 1 from it. The power is 1 here. What you do is you drop the power 1 and you subtract 1 from it, like so, obtaining dy dx equals, what is 4 times 5? 4 times 5 is 20x to the 4th power, and minus 6 by 4 is a 24x to the 3 plus 3x to the 0th power, and this is 20x to the 4th power minus 24x cubed, and x to the power 0 is a 1, and 1 by 3 is 3, and we have this, and this is the result. Pay attention to this because we are here on a journey to master mathematics and science together with technology. We want to be engineers, we want to be pilots, we want to be astronauts, and this is the way. So in the end, we're able to see, therefore, Mr. Examiner, dy dx is that equals to 20x to the 4th power, just copying the answer we got down here, 20x to the 4th power minus 24x to the 3rd power plus 3, and this is the result. We continue to explore even much more mathematics and science in a step-by-step fashion, and go with us as we explore this journey of mastering science, getting distinctions with 100% in mathematics and physical sciences. We continue with the next question. Right, so the next question is the dx notation. So we're looking at 9.2.2, we're looking at the dx notation. So if we need to calculate dx, what do? We calculate dx as follows. We take this particular question and we write dx. And this is minus the cube root x here out of 2 plus, you square everything here, and if you square everything, you can still write it as this, and you square everything, and this is what you get. Now pay attention, because we're going to decipher this, but also we're going to analyze this to its simplest possible terms. And now let us actually, solve this step by step. So you have here minus 1/2 x to the 1/3 plus. Okay, you square here, which becomes 1/9, 1 over x to the 2 dx. Okay, so is minus 1/2 x to 1/3, 1 over 9 x to the minus 2. x to the minus 2. Right, so we have the plus here. We have the plus here, and this is x to the minus 2, like this. So that we have dx, and this is 1/2x to the 1/3 plus 1/9 x to the minus 2. Okay, that's what we got. And now what we do with all this, we perform the differentiation. We bring down the power and we drop the powers. Let's see. Here we have minus 1/2. We drop the 1/3 x. We subtract 1 from the top. 1/9. We drop minus 2 and we subtract 1 from the top. Okay, so minus 1 by 1 becomes minus 1 out of 6. Actually, what is 1/3 minus 1? Minus 2/3. Okay, now here we have 1 times minus 2 getting minus 2 out of 9. Right, and we have x to the minus 3, like so. What then is the meaning of all these? What then is the meaning of all these? Please always write your answers with positive exponents. Students, we urge you with the mercies of God Almighty to make sure that you write the correct answers, but you write them in a way that will allow you to earn all the marks. We don't want you to miss marks. We don't want you to walk out of the exam and think you're going to 100%, but you were just writing for the sake of writing, but you're not following the rules. So now this is 6, and then it is x to the power 2 out of 3. Okay, and this is minus 2 out of 9x cubed. Okay, and this is what we have. And therefore, this is the answer to the question, because we are to determine dx of this expression, and we have found the dx like so. So yeah, it is awesome, and we have found that. We have found that. So there is another thing here that we ought to do, and let's explore the next concept. Right, let's explore the next question. Okay, the next question is about a cubic graph, and this cubic graph is a very interesting one. The graph of h at x equals x cubed plus bx squared. Here's another question, and we need to find the equation. But in this case, they did not give us the x-intercept. The question is, what do we do? Because Mamba was looking at that one, was like, okay, now they want us to find the equation. But you see, the examiner has given us h of x, which is ax cubed plus bx squared. And we just need to find, show that a is minus 1 and b is 6. But look at this. I mean, if you look at this very carefully, there are a couple of things that remain extremely important. Right, so the graph has turning points at the origin. There's a turning point at the origin, O with the coordinates 0 and 0. B has the coordinates 4 and 32. A is an x-intercept of h. We want to show that A is minus 1 and B equals 6. We find the derivative of this. So we're going to find whatever is needed. Okay, good. Let us think about what we need to do. There are a couple of points that are very important. Like we're able to see something about, for instance, the fact that there is a point whose coordinates are known. B. So we can use that point whose coordinates are known because it's a turning point, so we can find the derivative of this. So we find h primed, and bringing down the 3, it becomes 3ax squared plus 2bx. Okay, so, right, so obviously this point is x equals 4, which means h primed at 4 equals 3a, 4. 2b times 4. Okay. We have this derivative, but we know very well that this derivative is equal to, the derivative itself is equal to 0 at 4. Because at x equal to 4, there's a turning point, and this point here is called the local. It's called a local maximum. And this one here is called the local minimum turning point. Okay, at the turning point, the derivative or the slope of a tangent is 0, because any tangent to the graph will actually be horizontal and parallel to the x-axis, and therefore there's zero slope there. We square 4, we get 16, and 16 by 3 gives us 48. So this gives us 48a plus 2b by 4 will give us 8b is 0. Now we divide by 8 right through. Dividing by 8, we divide 48 by 8, you get 6a plus b equals 0. And at this point, we are having one equation to analyze. Okay, so we're using obviously this equation, and that is what right. So we continue. Right, we continue. Right, in continuing, we have the following. So we got an equation. So yeah, let's call this equation equation 1 that we've just got. And we're gonna get another equation right now. And in getting another equation, we have the following. So let us say this graph passes through. Right, so this graph passes through, and it passes through B. B has the coordinates 4 and 32. There's the coordinates 4 and 32, so you have x and y. And then at this point, you can substitute the y there in this equation. So you substitute the y into that. So the equation is h of x, which is the original equation the examiner gave. This is what we do when we are not given the intercepts. Okay, because one student was asking, Mamba was asking, what do we do? What formula do we use when we are not given the intercepts? This is one case where we're not given the intercepts, yet we can still find the equation. Right, so x and y. So y is 32 equals a, the x is 4 and you cube it, plus b 4 and you square that. So that in the end, what do we get here? You get 64. Okay, 4 cubed is 64. So it's going to be 64a plus 4 squared is like 4 by 4, giving us 16b equals 32. Right, so we have this here. Please pay attention because we are training you guys to become the best you can be. We can divide through by 16. Dividing through by 16, right? What is 64 divided by 16? It is exactly a 4, giving us exactly 4a plus b. If you divide by 16, dividing 32 by 16 would give us exactly 2. Look at these, and this is all good news. And yeah, it is worth celebrating. And we are in a celebratory mood. And let's get going. Let's get going. So that in the end, we have the following. 4a plus b. Right? So that we have 6a plus b equals that, which is minus 6a. So now you have 4a plus b. Okay, now 4a minus 6a is minus 2a equals minus 2. Okay, but this is 4a plus b equals 2, positive 2. It is exactly positive 2. It is 4a plus b equals positive 2. And this other one, you have 6a plus b equals 0. So this is positive 2. Right, so we therefore have minus 2a equals that. You divide, which is plus 2 here. And you divide both left and right by negative 2. Dividing by negative 2 on the left, dividing by negative 2 on the right, we have a equals minus 1. And this is the answer. So we got a equals minus 1, and it remains to obtain the last one, the numerical value of, for instance, the b. But we know something about that one. We know that 6a plus b is 0. 6a plus b is 0, which means that b is equal to 6. Okay, yeah, look, we've got b equals 6. We've got b equals 6. Okay, good. Here it is. B equals 6. We've got a equals minus 1. We've got a equals minus 1, and we've got b equals 6. So b equals 6, a equals minus 1. That is the answer. Okay, this is what we do to find the equation. So how do we find the equation? So the equation is going to be exactly h. They did not say just, they said just show that a is minus 1, b equals 6. So the equation is h equals ax cubed plus bx squared, which means h. What is a? A is minus 1. So this is going to be minus x cubed, and the b is 6. So you're going to put 6x squared. We have found the equation without using that formula of the roots of the 3x intercepts. Yeah, I did not use that one. Next question. Calculate the coordinates of A. Calculate the coordinates of A. Right, so to find the coordinates of A, you need to remember that our A is minus 1, our B is 6. We plug them into that, so which means that it is minus x cubed, and the B is 6x squared. Right, we want to calculate the coordinates of A, but A is what? What kind of a point is A? A is the, right, is an x-intercept. It is an x-intercept. How do you deal with the x-intercepts? You let y be 0. Minus x cubed plus 6x squared equals 0. Pull out x squared, and we have minus x plus 6 equals 0, which means x is 0 or x equals 6. Right, so if x equals 6, therefore we want to find the coordinates of A. So the coordinates of A are when x is 6, y is 0. On those will be the coordinates of A for the 3 marks. So here we would say the coordinates of A are A with the coordinates 6 and 0. A with the coordinates 6 and 0. Right, so you can ask a question if you have. And we move on to the next one. We're mastering all calculus. Please, I also did a video earlier on from 4 to 6. So I'm going to post those videos, all of them, after 10, when I'm done with everything, because I've not posted the video of 4 p.m., but I'm going to make it available. Now, here's the graph, and the examiner says, write down the values of x for which h is increasing. So now, when it comes to the decreasing part, here the function is decreasing because it's going down. Here the function is increasing, is going up. Here the function is decreasing, is going down. And here we're referring to the h primed, the derivative, the gradient of this. That is what the signs are for. So write down the values of x for which this function is increasing. So increasing is here, so is x 0. Yes, please, Nambuso. Any question, Nambuso? So you can see that the function
No.
is... Yes, how are you? Welcome, welcome, welcome. You have a question?
No.
Okay, that's fine. So write down the values of x for which h is actually increasing. So h is increasing. We can see that it's when the function is going up slope like this. When x increases, we can see that the function is decreasing here. When x increases, we can see the function is increasing here. When x increases, the function is decreasing there. So we just put these signs to remind ourselves. So increasing means that it has a positive gradient. And that is happening here between x equal to 0 and x equals 4. So x equals 0 and x equals 4, that's when the function is increasing. Now, when is the function concave down? When is the function concave down? Right, so let us analyze where the function is concave down. So to find where the function is concave down, we consider the following. Let's remember what the equation of the function actually is. we were given h of x equals ax cubed plus bx squared. So h of x equals minus x cubed plus 6x squared. This is the defining equation of the given cubic function. We want to determine where it's concave down, and concave down is best seen in terms of the derivative. So the second derivative, which is the is subject to the inflection point. The first derivative of this is, okay, when you want to find the first derivative, you drop the 3 and you subtract 1 from the 3, getting a 2. You drop that 2. If you drop that 2, then it's going to be 6 by 2. What is 6 by 2? 12. Right, 2 minus 1 is power 1. We don't write the power 1 there because it's trivial. So now we then continue to do the following. Right, when is the function concave down? We must find the next derivative. Concave down, we must find the second derivative. So now we drop 2, and 2 times minus 3 will give us minus 6x. Minus 1, you get a 1. Okay, here there's power 1. You have 12 by 1x to the power 1 minus 1, which is 0. Getting the second derivative, which equals minus 6x. Right, getting the second derivative, which is actually minus 6x plus 12. Look, it's concave down. Concave down means what? Concave down means that you have that, so we can write that one down. I want to write it step by step. I want to write it step by step. So you come here in the question of 10.3.2, you write concave. Concave down. Concave down would mean, therefore, that h double prime of x is negative, which means that minus 6x plus 12 is negative. Right? So we now need to solve for x, which means that 6x is less than minus 12. So we have minus 6x, you divide the left by minus 6, but also when you have 12, you divide by minus 6, then inequality must change direction. Right, if it changes direction because we're dividing by a negative number, we then have x here is bigger than 2. We have x there is bigger than 2. If you don't want to write x is bigger than 2, we can write the following. We can say x is an element of, because if you are on the real line and you put 2 here and x there, x bigger than 2, you're going to the right. Right, so you're going to right, which means 2 and that. 2 and infinity. Semicolon here, semicolon. This is the answer. Where's the question on concave down functions? Some functions are concave down, some functions are concave up. Some functions are concave down, some functions are concave up. What is the next point? 10.4. Right, so 10.4 now is a very exciting one, and we continue to solve more problems. And we look at the 10.4. Right, in 10.4, they're saying for which values of k will this particular equation have 1 negative and 2 distinct positive roots? Okay, let us analyze this together. And I want us to remember something about the function itself. Would remember that this function is sort of like this. Right, and there's a point here where you have 4 and 32. Here, the function is in contact with the origin, and this is exactly what we have here. And you have A here, and we've been able to get the coordinates, and the coordinates of A are exactly 6 and 0. For which values of k will minus, open bracket, x minus 1 cubed plus 6, open bracket, x minus 1 squared minus k equals 0 have 1 negative and 2 distinct positive roots. I want us to focus on this question. 3 marks, but understand this very, very well. So which means, therefore, you'd have h. H of x, which is minus x cubed plus 6x squared. Okay, that's what you got. And that is the equation here. But the examiner has transformed the equation. There is a transformation. Right, there's a transformation. What transformation of this function are we talking about here? So it is a transformation because now we can see a translation. But now look, the examiner is very smart and he's making sure that it throws you off. They make sure that they get you so confused. What you can do, you transpose the constant k to the right-hand side, getting this equal to k. But now pay attention to the things that matter. We're moving forward. We are moving forward. So this function here is translated. If you subtract 1 from x, it means that it is moving by 1 unit. 1 unit right. Right, so this graph is going to move 1 unit to the right. So if it moves 1 unit to the right, it means that you shall have the following. So I'm going to do it in green color. In green color. 1 unit to the right. So it's 0, 1. 6. 1 unit is going to be at 7 here. Okay. The graph is going to be the green one. If it moves 1 unit to the right. And then here it's going to be at 1 unit to the right, it's going to be at 5. Because it's 4 here, it's going to be 5. But the y is going to remain the same. Okay. Same level. This is not to scale, but take note of the transformation. So now then, what then do we have? So for which values of k will this have 1 negative and 2 distinct? So this, if this is equal to k, so you're gonna draw. You're gonna draw. Let's do it in purple. So you can draw like this, a line, okay? Because this is like another curve, but a constant function. Y equals k. Okay, it cuts through like this and it cuts. Okay, it's gonna cut at, we're focusing on the green one, it's gonna cut at 3 distinct points. But the examiner does not just want that. They want 1 negative and 2 distinct positive. Right, so if it is to cut here, for example, you would have what? Right, so you would have 1 negative root and only that. So, but if you come here, what then do you have at that point? If you come here, you have 2 positive, but they're not distinct. And you have also another root there. Okay, so let us analyze this particular question very, very well and see what then the answer becomes here. So the question then in 10.4 is, what then do we need? If it happens that at this point, y is 32, y is 32, and if y is 32 and you go further down, to, okay, at y 32 now it's going to cut here and it's going to be at a couple. Remember that this is not to scale. It's not to scale. So the negative root, let it occur when this one is like this. So that there's a negative root here. There's a negative root when this is going to cut here. So there's going to be a negative root, which is 1 negative root and 2 distinct positive roots. This is so untidy, but yeah, just have an idea of what's happening here. Have an idea of what's happening. So I'm going to consider the I'm going to consider the purple, okay, and the red. Right, so if this is the case, what then do we have? Okay, so we continue. Okay, so if it cuts like this, the horizontal one, it's going to have one negative x value here. It's only negative x values. X is negative here. And there's going to be an intersection on this side, but x is positive there. But x is positive there. Right, x is positive there. So in the end then, what does it mean? It would mean a couple of things, but it will be very interesting for us to take note of the fact that this negative can only last a little bit. It can only last a little bit. So the question is, what is the intercept here? What is the intercept here? Because we can only get the negative intersection here between the y-intercept here and the highest y value, which is 32. So we need to find the y-intercept. We need to find the y-intercept. Y-intercept of h, which is minus x minus 1 cubed plus 6x minus 1 squared. What is the y-intercept? To get the y-intercept, let x be 0. H at 0 minus 0 minus 1 cubed plus 6, 0 minus 1 squared. H at 0, and this is minus, getting us a 1 plus 6, which equals what? Which equals 7. Okay. This means what? We then have that it's going to cut at 7 there. And this one here is going to be at 32. So if we to make sure that this horizontal line is going to cut at an x value that is going to be negative, but also it's going to be intersecting the purple curve at two distinct x values, it means therefore that our k will have to lie between 7 and 32. 7 and 32. If we want to give the answer like this, we'd have to say k is an element of the interval from 7 to 32, like so. We move forward. We proceed to the next question. The next question is very beautiful. But after traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close a tap in his garden. He traveled the distance of 20 kilometers, but he realizes that, hang on, I did not close a tap in the garden. So he decides to turn around. Remember, this guy traveled the distance. He decides to turn around immediately and return home to close the tap. The cost of the water at the rate at which water is flowing out of the tap is 160 per hour. The cost of petrol is 1,2 plus x over 4,000 rands per kilometer, where x is an average speed, or rather is the average speed in kilometers per hour. Calculate the average speed at which the person must travel home to keep his cost as low as possible. Let's continue now and tackle this question step by step. Now, we need the time here, but we need to go back to grade 10 and remember what we did at grade 10. So this is what we do. We then say that whatever we do at this point, and we need to take note of the fact that x is the average speed in kilometers per hour. So we have that speed. Right, so, and we can say it is speed. Obviously, it is, as the examiner says, average speed. Right, so the average. The average speed is X kilometers per hour. So which means that if the average speed is like, so we know that speed equals distance over time. Right, so speed equals distance over time. And the cost of petrol is that one. And the cost of water, the rate of which the water flows out, is 1 rand per hour. So the question then is, if we are interested in performing the calculations, we'll have to calculate the time. The time here. The time this person will take to travel. So he she travels a distance of 20 kilometers. So we know that time, according to this, time is distance of a speed. Time is distance of a speed. What is the time? And therefore, time is distance. What is the distance? 20 kilometers over the speed. What is the speed? The average speed is X. So the time this person is going to take is 20 out of X. Calculate the average speed at which the person must travel home to keep his cost as low as possible. So we're interested in the cost. We want the cost to be as low as possible. So we're going to do the cost. The cost is water cost per hour. Water cost per hour multiplied by the time. Plus water cost per hour multiplied by the time. Kilometers multiplied by the rands per kilometer. So in other words, the cost will be the water cost per hour times time, the kilometers times the rands per kilometer. Okay, so there are two costs associated with that. It's the water and the petrol. The cost of the water and the cost of the petrol. So we have the cost. Okay. Now, what is the cost of the water? Right, so we know very well that the cost of the water at the rate at which water is flowing out of the tap is 1 rand 60 per hour. 1 rand 60 per hour multiplied by the time. The time is 20 divided by X. But please, I said already, every day this week, 8 p.m. is math science. Math science in that alternation, please. We need to move forward here. Kilometers. Now, we have kilometers per hour times the rands per kilometer. So the kilometers per hour would be what? Or the kilometers. This guy is going to travel 20 kilometers. So here for kilometers, you do 20. And now you have the rands per kilometer, which is this. 1,2 X over 4,000. Like so. What is the cost? What is the cost? 32 out of X plus 24 plus 20 goes times into 4,000 goes 200 times, and this is X over 200. So we multiply here by the 20, and 20 cancels. Factor 20 out of 4,000, giving us 200. And this is the answer. Okay, we're not done yet. So, but it is telling us that the cost is actually equal to 32 out of X. 32 out of X plus 24. 32 out of X plus 24 plus X out of 200. Like so. And this is then the cost, we can call it C as a function of X. 32 of X, 24, X out of 200. x out of 200. Which means that you have c primed of x. Okay, before we do the c prime, let's do c of x and write it in power form, which is actually 32x to the power minus 1, 24 plus x over 200. So this one is minus 32x to the minus 2 plus 1 over 200. Okay, and therefore, we want to make these as low as possible, so we must equate these to 0. So we must make the derivative equal to 0. All right, so obviously we take note of the fact that at this point, what we then have is the fact that you bring down the power, which is minus 32 x to the minus 2, and the derivative of the x is 1, giving us 200. So we have the following. Now, you can move things around here, like moving these to the other side, getting 32x to the minus 2 equals 1 over 200. We cross 32x squared. Yeah, 200 by this. So now we have x squared by 1, which is x squared, and 200 by 32, which is 6,400. We take the square root of x squared. We equate it to the square root of 6,400, so that x equals the square root of 64 is 80 kilometers per hour. And this is the speed. So you're asking the question, calculate the average speed at which the person must travel home to keep his cost as low as possible. And the average speed to keep his cost as low as possible, he must travel at a speed of 80 kilometers per hour. He must travel at a speed of 80 kilometers per hour. 80 kilometers per hour. Just take note of that. So if he travels at a speed of 80 kilometers per hour, then he's going to be so good. He's going to be so good. Where's the question? Where's the question? Right, in the absence of questions, I'm going to call it a very good evening. I'm going to see you again tomorrow, every day at 8 p.m. this week until June. Until June. Until you close, even so you prepare. If you are busy, it's okay. We understand that. But my point is, we're encouraging everybody to attend the lessons. Why? Because we want you to improve. We want you to become medical doctors.